Every time your Netflix buffers, every time your Zoom call drops, every time your online game lags and someone accuses you of cheating, that's a protocol problem. Specifically, it's about a choice someone made, TCP or UDP. These two protocols are responsible for moving virtually every byte of data you interact with every day. And they solve the same problem, getting data from A to B in radically different ways. By the end of this video, you'll know exactly what those differences are, why they exist, and when to use each one. Let's go. First, some context. The internet doesn't send data as one big blob. It breaks everything into small pieces called packets. Each packet can travel a completely different route across the network, and they might arrive out of order, late or not at all. So the question becomes, how does the receiving end deal with that chaos? That's exactly the problem TCP and UDP were designed to solve. They both sit at what's called the transport layer. They're the rules of the road for how packets get sent and received, but they answer the chaos question very differently. Think of it like this. If IP is the postal service that delivers letters, TCP and UDP are two different types of mail. One requires a signature, one just drops the envelope and runs. TCP stands for Transmission Control Protocol. The keyword, control. TCP is obsessed with making sure everything arrives correctly, in order, and completely. Before TCP sends a single byte of real data, it does something called the three-way handshake. Your device sends a SYN, "Hey, can we talk?" The server replies, "SYN-ACK. Yeah, I'm here." You send back an ACK. Great, let's go. Only then does data start flowing, and it doesn't stop there. Every packet TCP sends gets an acknowledgement. If the receiver doesn't confirm it got a packet, TCP resends it. If packets arrive out of order, TCP reassembles them correctly. If the network is congested, TCP slows itself down to avoid making things worse. This makes TCP incredibly reliable, but reliability has a cost. Overhead. All those handshakes, acknowledgements, and retransmissions take time. There's latency baked into the design. So where do you use TCP? Anywhere correctness matters more than speed. Loading a web page, HTTP and HTTPS run on TCP, sending an email, transferring a file. If even one byte is wrong or missing, the whole thing breaks. TCP handles that. UDP, User Datagram Protocol, shush, doesn't care about any of that. No handshake, no acknowledgement, no retransmission. UDP grabs your data, shoves it into a packet, and fires it off into the network. Done. It doesn't know if the packet arrived. It doesn't know if it arrived in order. It doesn't slow down for congestion. It's what engineers call connectionless. There's no relationship between sender and receiver, just a one-way blast of data. That sounds terrible. Why would anyone use this? Because for a lot of applications, speed matters more than perfection. Think about a live video call. If a video frame arrives late, you don't want TCP to pause everything and wait for a retransmission. By the time it arrives, it's useless. It's better to just skip it and show the next frame. A little glitchy video is far better than a frozen, stuttering call. Same with online gaming. If your position packet from 100 memories ago gets dropped, you don't want the game to freeze while it retransmits. Just send the new position. The old one is already irrelevant. DNS lookups. The thing that translates google.com into an IP address uses UDP too. The request and response are tiny. If it gets lost, just ask again. No need for the overhead of a full TCP connection. Let's put them side by side. TCP requires connection setup, guarantees delivery, guarantees order, retransmits lost data, has congestion control, higher latency, more CPU and memory use. UDP, no connection needed, no delivery guarantee, no order guarantee. Lost packets stay lost, no congestion control. Lower latency, lighter resource use. The mental model. TCP is a phone call. You establish a connection, have a back and forth conversation, and hang up properly. UDP is a walkie-talkie. You press the button and broadcast. Whether anyone hears it or not is their problem. Here's where it gets interesting. This isn't a clean TCP good, UDP bad story. Modern apps blur the line all the time. YouTube and Netflix actually use TCP for video. They use large buffers to hide the latency. WebRTC, which powers most video calls in browsers, runs on UDP but builds its own reliability layer on top. And Quick, the protocol behind HTTP 3, uses UDP at the base but implements all the reliability features of TCP itself, with better performance. The real takeaway? The protocol is a tool. The choice between TCP and UDP is a trade-off between reliability and speed, and smart engineers pick the right tool for the job or build something new on top of UDP when neither is enough. That's TCP versus UDP. If this clicked for you, the next logical step is understanding how HTTP actually works on top of TCP. I've got a video on that linked right here. Subscribe if you want more networking fundamentals broken down like this, and I'll see you in the next one.